This is the second presentation on the endocrine system, and in this presentation we will discuss the secretions of the pituitary gland. The pituitary gland is also called the hypophysis. It is a short stalk that hangs from the bottom of the hypothalamus, and it has a front and back part. The posterior pituitary, also called the neurohypophysis, is generally an extension of the hypothalamus, the nerve tissue of which it is made, because it is actually felt that the hypothalamus make these hormones, but they are stored in this part. On the other hand, the front part, the anterior pituitary, is called the adenohypophysis. This is glandular tissue. This makes 6 secretions that we will look at. The posterior pituitary's hormone, one of the two, is ADH, antidiuretic hormone. It is also called vasopressin. It is a peptide hormone. And here, again, we mentioned in the first one that we were stressing the function of each hormone, and then the stimulus, or the situation in the body, where more will be secreted. So, the stimulus here is decreased water content of the body, and the function, it increases the reabsorption of water by the kidneys. So rather than the water being part of the urine and leaving the body, it will be taken back in to the bloodstream. So when the water content is lower, or dehydration would be another term, this helps the body hang on to water. There are osmoreceptors in the hypothalamus that detect the saltiness of the body fluids. So if it's more salty, there's less water, and if it's less salty, there is more water. So the less amount of water is dehydration. And it has its name vasopressin because when large amounts of it are secreted, the vessels constrict. So we have vasoconstriction. Alcohol consumption inhibits secretion of ADH. So if one is consuming alcohol, one puts out more urine because less ADH is secreted. The second hormone of the posterior pituitary is oxytocin. It is also a peptide hormone. And it has 2 jobs, 2 functions. One, it stimulates contraction of the uterus to deliver the baby, and it stimulates the release of milk from the mammary glands. This is called letdown. It makes the milk flow so the baby can have it. So it has 2 stimuli then. One of them is delivery of the baby. And here again it gets its cue that that's happening because the cervix begins to stretch. It is a positive feedback because as delivery continues, it will continue. When delivery stops, it stops. And its other stimulus is suckling of the baby. So here again, it is produced when the baby is going to consume the milk. So it has 2 stimuli. Oxytocin is present in males as well. So it is felt that it influences the nurturing aspect of a person and its trustfulness. Now we will look at the front part of the pituitary, the anterior pituitary. Its secretions are influenced by releasing hormones from the hypothalamus, and they're secreted into the capillaries of the hypothalamus. Then they exit the hypothalamus by the hypophyseal portal veins and go to the capillaries in the anterior pituitary. We will look at these 6 hormones. The first one is growth hormone, GH, or somatotropin. Its function is to increase the rate of protein synthesis. That's the one we're going to focus on. It also increases the amino acids entering the cells. And here again, its stimulus is a releasing hormone for the hypothalamus. And we're going to focus on exercise because here again, when you're doing things, you need protein synthesis to make structures, to make those, if you remember, the substances that influence metabolism. So therefore, you would need GH. So we'll just focus on exercise, but we will also know that it is increased by hypoglycemia, a low blood sugar, and high amino acid level in the bloods. But like I said, we're focusing on exercise. There's an inhibiting hormone too that controls it from the hypothalamus called somatostatin, or GHIH. We're not focusing on that area though. Another one is TSH, or the thyroid stimulating hormone. Its function is to stimulate the growth of the thyroid and the secretions T3, triiodothyronine, and T4, thyroxine, made by the thyroid. And the stimulus, obviously it has a releasing hormone from the hypothalamus. And when the condition in the body is that the metabolic rate is slow, or the metabolic rate decreases, then the TRH from the hypothalamus influences the pituitary to make the thyroid stimulating hormone. Another one, ACTH, adrenocorticotropic hormone. And here again, this stimulates the cortex of the adrenal glands to increase their secretions. And the stimulus, here again, is a releasing hormone from the hypothalamus, and what the body condition would be what we call physical stress. Anything that's going on excessively, then ACTH will be made. The next one is prolactin. This initiates the production of milk by the mammary glands. And here again, it is stimulated by a releasing hormone from the hypothalamus and delivery of the baby and nursing or suckling. So this we're looking in deference to oxytocin lets the milk flow, but prolactin makes the mammary glands make it. So when the baby is delivered, it's ready, the milk is ready for the baby, and then if the baby continues nursing, it will continue to produce milk. The next one is FSH, follicle stimulating hormone. And this has two functions, because one for the male and one for the female. In the female, it stimulates the growth of ovarian follicles, which hold the eggs, and the secretion of estrogen. In the male, it basically stimulates sperm production. Here again, it has a releasing hormone, and we'll just focus on that. And then, of course, there is an inhibin, but on the other hand, that when much is produced, it will decrease the amount of it. But we're just focusing mostly on FSH as its function. And then we've got LH, luteinizing hormone. And here again, we've got the female, where it stimulates the release of a mature egg and the development of the corpus luteum. And we'll get more into that, but the corpus luteum is what the follicle after the egg is released. And in the male, it stimulates the interstitial cells of the testes to secrete testosterone. And here again, we're just looking at that releasing hormone from the hypothalamus as its stimulus. So that finishes up the secretions of the pituitary gland.